Welcome to Shanti-Peace for Mathematics. In this video, we'll discuss regarding the higher order derivatives. So if the f is a function which is a derivable function, and up to now what we have studied is differentiating this function f up to first order, that we are denoting as f dash. Second order, it's also another notation is df by dx, d square f by dx square. But the successive derivative of f represented by the symbol f dash, f double dash, f triple dash, up to so on f nth derivative of that, or d square f by dx cube, up to so on d cube d power n y by f y by dx power n, so on. If your function y is equal to f of x, then the functions are denoted as y1, y2. That means the first derivative, second derivative, yn, y3, and then so on yn is the nth derivative of that. So in general, these are the notations to denote the higher order derivatives. And if you want to calculate the higher order derivative at particular point, then the notation is the nth derivative of f at point A is denoted as this. Also, it can be denoted as d power n f upon dx power n at x is equal to A, or it may be denoted as yn at A. So these are the notations for the higher order derivatives which we are following for this course. So in that, the first things which we are going to discuss is to know what are the well-known functions whose nth derivatives are what. So that means a function is y equal to e power mx, exponential function is there. Then what will be the nth derivative of this function? We know that the first derivative is m into e power mx. Using the chain rule, we can got this. The second derivative you will have, as m is a constant with respect to x, so it is m into, again the derivative of e power x is m into e power mx. So the finally you will have m square e power mx. And the third derivative in the similar manner you will have, it is m cube e power mx. So this idea leads to conclusion that the nth derivative of this will be m power n e power mx. But now the question is, can we prove this statement? To prove this statement, we'll need to recall what is the principle of mathematical induction. So the principal mathematical induction is this: if you have any statement Pn where n is a natural number, and then we have to determine whether this Pn statement is true for every n which is a natural number, then you have to follow the following three steps. Check whether the statement n equal to 1 is true. The second step is to assume the pk is true. That means assume that the statement given Pn is also true for n equal to k for any given positive integer less than n. Then the third step, you have to prove that the pk plus 1 is true for any integer k. And if you follow these 3 steps and it is conditions are satisfied, then we can say that the Pn is true for any natural number n. Now let us try to make out what is the conclusion out of this and make a statement for that. So we'll call it as a theorem. If y is equal to e power mx, where m is any real number you can take and x is also a real number, then a yn is m power n e power mx for any n belongs to n. So if I want to prove this statement, I have to use the PMI. So because this statement is depends on n set of all natural numbers. So we'll write first that we shall prove this statement using PMI. Consider your statement P, that is Pn, as yn is equal to m power n e power mx, n belongs to n, when y is equal to e power mx. So as per the PMI, you have to prove that result is true for p equal to n equal to 1. Here what we have given, y equal to e power mx is in front of you. So if I take the derivative, both side with respect to x, then we get y1 is equal to derivative of e power mx is e power mx, and using the chain rule the derivative of mx is there, then the derivative of mx we know it is m into e power mx. So if you can compare with this one with this statement Pn, then whenever n is there we have here 1. So therefore I can say that P1 is true. Now we have to assume that Pk is true. So assume that the statement Pk is true. Once you assume that Pk is true, that means Yk is equal to where k belongs to n and k is less than n. That you have to assume. Then your Yk is m power k e power mx. Now since Yk is here, that is the kth derivative will be there. You can taking the derivative with respect to x, both side, we get yk plus 1. Because this is a kth derivative, if you are doing one more the derivative of that can be written as d by dx of yk, that is d by dx of m power k e power mx. But m power k is independent of x, so that I can write down outside this derivative, and d by dx, that is the first derivative of e power mx, we already calculated, it is m power k into m into e power mx. So that will give you m power k plus 1 e power mx. And if you compare with the yn statement, whenever we have n, it is k plus 1. So we can say that therefore pk plus 1 is true. Therefore by PMI, Pn is true, and hence if y is equal to e power mx, then yn, that is the nth derivative of y, is another function. Let us consider the function y is equal to a power mx, where a is any positive real number. M is any real number and A is any positive real number. Then we know that the first derivative of this one is a power mx into log a base e into m. A second derivative will be a power mx log a square into m square. And if you go in this manner, we can see that the nth derivative of this function is m power n log of a power n a power mx. So now we can make out the statement from this discussion is that if y is equal to a power mx, if m is belongs to R and a is greater than 0, then yn is m power n log a power n a power mx. Let us try to prove this statement. Again, this statement is true for any n belongs to n, that is there. So this statement is depends on n. So I will prove this result using PMI. So we shall show that the result is true using PMI. So let us consider this Pn statement. Pn is yn is equal to m power n log a power n a power mx when y is equal to a power mx. Here the yn denotes the nth derivative of y. So here what is the function is given, y is equal to a power mx is there. So taking a derivative both side with respect to x, we get y1, that is a derivative of a power mx, that is a derivative of a power mx will gives you a power mx into log a, and the derivative of mx will gives you m. So it is finally m into log a into a power mx. And if you compare this statement with our Pn statement, we can see that whenever we have n, we have 1 here. So that's why I can say that the statement P1 is true. The next step is to assume that Pk is true. So assume that the statement Pk is true for all k belongs to n and k is less than n. That means yk we have assumed that m power k log of a power k a power mx. Since this is kth derivative, the next step, the third step we have to prove for the result is true for k plus 1. So for that I am taking a derivative both side with respect to x. We obtain that yk plus 1, which is d by dx of yk, which I can say d by dx of m power k log of a power k a power mx. But this quantity is independent of x. So using the rule of the derivative, I can say this is this. And the derivative of a power mx, which we already obtained here, that is m into log a into a power mx. So it is m into log a into a power mx. And if you combine both this, that is m power k plus 1 log of a power k plus 1, and it is a power mx. So from this, what we can say, that result is true for pk plus 1. So I can say that the statement pk plus 1 is true. And hence, by PMI, we can say that the Pn is true for all n belongs to n. So finally, what we can say, if y is equal to a power mx, then the nth derivative of this is m power n log of a base e power n a power mx. Let us solve few more theorem like this. So the very important functions, which is a class of trigonometric functions, the obvious questions arise: what will be the nth derivative of sine ax plus b if this ax plus b is a real number? So as we know that the first derivative is cos ax plus b, and the derivative of ax plus b will gives you a. The second derivative will have a square sine ax plus b, because the derivative of cos is minus, so that's why it is a minus sign. The third derivative of this one is minus a cube cos ax plus b, and the fourth derivative is plus again a power 4 sine ax plus b. And then if you do the fifth derivative, then it will again a sine function is that, but it is a power 5 will be there. So ultimately, what is happening here, the cos is changing to sine in each time you derivative. Also the negative sign will also change after fourth time. And we have one technique to convert the function sine into cos is by adding the theta into the pi by 2. That means we have a formula that sine theta plus pi by 2 will be cos theta. If I can use the statement here, I can replace this cos theta by sine theta. So this quantity I may write down in terms of sine theta as a sine theta, that is theta is ax plus b here, plus pi by 2. And similar manner, we have the formula like sine theta plus pi will be minus sine theta, because theta plus pi is changed its quadrant. It is a third quadrant. If theta is in first quadrant, then this is in third quadrant, and so sine will be changed. So this is minus sine theta, we can write as a square sine ax plus b plus pi, but pi I can write down as pi by 2 into pi upon 2. Again, using the same concept as sine theta plus pi by 2 is equal to cos theta, we may write using the concept that theta sine theta plus 3 pi by 2, it is minus cos theta. So using this concept, we can say that minus cos theta is a cube sine ax plus b plus 3 pi by 2, and the next one is again adding pi by 2 into that, so that is a power 4 sine ax plus b plus 4 pi by 2. Actually we have added 2 pi here, and theta will not be changed. And you can observe that using this, we can say that the nth derivative of Sine ax plus b is a power n because it is power 1 here, power 2 here, power 3 here, power 4 here, and the sine ax plus b is already there, plus it is pi by 2, it is 2 pi by 2, second derivative, third it will be 3 pi by 2, fourth will be 4 pi by 2, so that is it is n pi by 2. So this is the statement we can make, that if y is this, then the yn will be this one, and then a next task is to prove the statement. So let us state that is, if y equal to sine ax plus b, if your ax plus b which is in a real number, then prove that yn is a power n sine ax plus b plus n pi by 2, where your n is in natural number. Again, we will use the principle of mathematical induction to prove this statement. So we shall use PMI to prove the statement, prove the above statement. So consider the statement Pn as yn equal to a power n sine ax plus b plus n pi by 2, where y is equal to sine ax plus b. So here what we have is y equal to sine ax plus b. The first task is to prove the result is true for n equal to 1. To prove the result is n equal to 1, we have to take the derivative. That means it is a first derivative we need to calculate. So taking the derivative, both side with respect to x, we get y1 is equal to the derivative of sine, we know it is a cos, and using the chain rule, that is a d by dx of ax plus b we can write, and if you simplify that, it is a cos ax plus b, and we know that the formula for changing the sine into cos is sine theta plus pi by 2 will be cos theta. So using this we can say this is a sine ax plus b plus pi by 2. So therefore we can say that the statement P1, the statement P1 is true. Now the second step says that we have to assume the result is true for n equal to k. So assume that the statement Pk is true. That means yk is a power k sine ax plus b plus k pi by 2. For every k it is in n and k greater than n, sorry, less than n. Now this is a yk. The next step is to prove the result is true for k plus 1. So I need to differentiate this to get the k plus 1th derivative. So taking derivative both side, we obtain yk plus 1. A power k is independent of x, so we can write down outside. The derivative of sine, we know it is a cos ax plus b plus k pi by 2, and the derivative of by chain rule we can say it is ax plus b plus k pi by 2. So this is gives you k a power k cos ax plus b plus k pi by 2. Again the rule which we have stated here, that is sine theta plus pi by 2 is cos theta. We can say that this is a power k plus 1 cos ax plus b plus k pi by 2 plus pi by 2, which will gives you a power k plus 1 cos ax plus b plus k plus 1 pi by 2. And so we can say that the result is true for k plus 1. Therefore, the statement pk plus 1 is true. So hence, by PMI, the statement Pn is true for all n belongs to a natural number. Therefore, if y is equal to sine ax plus b, then yn is a power n sine ax plus b plus n pi by 2. Now the next natural question one can ask, that if y is equal to cos ax plus b, then what will be the yn? And I'm giving you this is as a homework. You can try by yourself to do this. Try to formulate this formula, and whatever the formula you formulate using PMI, try to prove it. That's it for this video. If you like this video, please press the like button. If you have any comment, suggestion or question, please drop down in the comment box below. See you.